think it read like 200 or something like that. Okay, so as you just saw there, it was reading a voltage of 215 volts, which in reality is somewhere around 2150 volts. And that's because we have this voltage divider that's dividing it by a factor of 10. So the setup is we have a 12 volt car battery. I think it's lead acid, and I think if I charged it up, this thing would be reading probably a lot more, but I don't want to push it because I think the ZVS driver is only rated at, actually I don't know how much it's rated, but I just don't want to push it. And that's the flyback transformer that I showcased in another video. The the secondary is 3D printed, and I don't know how many windings I ended up doing, but because I made this like a couple months ago. But yeah, here you can pause the video if you want. And it's encased in what is this, mineral oil, something like that. It's to prevent arcing between the windings. But you could probably use any type of oil, I'm not really sure. And this is the full bridge rectifier. So that's how it is, and I have it connected to these screw terminals. The AC is connected to these two. Turn it on. Okay, so that's the DC voltage. It just uses 4 high voltage diodes that was taken from a microwave, and I think it's rated at like 20 kilovolts, something like that. So it's probably, yeah, there's no way I'm gonna actually exceed that. So yeah, and you see the input is there, and you get the DC voltage out. The voltage divider there is inside of a bottle, because I actually would not recommend like handling the circuit itself while it's running, because the voltage there's like a breakdown voltage, and it could arc over something like that, and you could get seriously hurt. So put in something. I just put inside of a orange juice bottle, and it's all soldered on a PCB. I think there was like 22 resistors, something like that, on there, and that if each one is rated at like 200 volts, right? That's like close to 5 kilovolt rating in total. And it's wired in series. Each one is 360 kilo ohms, I think. And then I messed up some of the resistors while wiring it together, so I just replaced 3 of them with like a 1 mega ohm resistor, which should still come out to like 9 mega ohms in total. And of course that's just connected to the DMM, and that's on the 1000 volt rating. And all you just have to do is just multiply it by a factor of 10 to get the actual reading. And so then push out 2 kV. So now I know how many stages in my for my voltage multiplier that I need to get to power like an X-ray tube, which requires way more. It's like 80 kV or something like that. So I'm gonna probably do that circuit next. If you're planning on making one of the high voltage probes on your own, one thing to note is these ranges here, they all have different impedance. So if you try to divide the voltage on like a 10 volt range, then it's gonna divide the voltage differently if you're gonna use it for a 1000 volt range. So what I would recommend, if you're gonna rely on the impedance of the multimeter, is to just measure do your test voltage on 1000 volts, and then and then it'll divide it correctly on the 1000 volt rating, or whichever rating you're gonna do. So this is the formula that you use, where VR is your output series voltage. R is a resistance, the resistance of a resistor that you're putting inside a circuit. VB is the voltage of the battery you're measuring. So if you want to see how much impedance the multimeter has in your voltage, you connect a power supply to your circuit and then use an arbitrary resistor, like with like an arbitrary resistance, and then using this formula you can find out the resistor inside the multimeter, and then from that, if you multiply it by 9, you can then divide whatever incoming voltage into the multimeter and divide it by 10, or whatever, how many, whatever factor you want to divide it by.